Hello everyone. Welcome to Code Guide. And today we'll start with Python. And the topic we are covering in this session is language syntax. And we'll cover important topics like indentation, Python variables, reassigning values, indexing elements, the arithmetic operator, the logical operator, comparison operator, identity operator, line continuation. And we'll also discuss and do the implementation part where we will get the better understanding about the language syntax part. So let's start. So Python is a prominent programming language widely adopted within the data science field. Quite true, as it is more simple to use, easy to read, and easy to implement. So it is an prominent programming language. And the core liquidate Python's technical advantages and introduces its modules tailored for scientific computing application. And its robust functionalities make Python a preferred language for disciplines such as finance, econometrics, data science, and machine learning. So basically, in this part or the session, we will be able to understand the building blocks of Python code. So as we know, Python is known for its clear and readable syntax. It is quite easy to read as well as implement also. So understanding the basic rules of Python syntax is the first step in learning to code. Okay. Now, first of all, we'll start with the syntax. So syntax means the rule that defines how we write program. And in Python, syntax is designed to be very simple and readable. Now we'll start with the indentation. So Python uses indentation to define blocks, not braces. Like in C and C++, we use the braces. So indentation is mandatory in Python for defining the structure and scope of code block. And if it is correct and consistent, indentation is crucial for the interpreter to understand the program logic. And indentation serves as a syntax for grouping statements, ensuring proper code execution. So generally, when we define indentation, so proper fixes, proper symbols, and proper defining the variables is very important. So there are multiple rules here. So basically, if we consider the if statement, so after if statement we mentioned was a particular boolean value like true, if true, and then we print indented block suppose. So that is the best example of how we should write the if else code block, or how we should write the function in Python, or how we need to declare the variables, what rules must be followed while declaring the variables, while defining the class, while defining the function. So these are the steps and what we can say the rules to how to write the code so that the Python interpreter could understand what we are trying to say. So proper defining the structure and scope of proper defining the structure is very important. And indentation serves as the syntax for grouping statement. Syntax basically means the rule that how we should write the our program, and it ensures proper code execution also. If proper indentation is not followed, our code will not be executed and will get error like syntax error. So which is not good. And if you follow the proper rules, will not get the basic error, which is the syntax error. Now we'll see the Python variables. So one of the main concepts in programming is the variables, and they are your best friends. You will deal with them all the time, and you will use them to store information, and they will represent your data input. Now, as you can see here, I have written some code that x is equal to 5. Now, in this case, x is the variable and 5 is the value which we have stored in that variable. So when we assign any value, so I've written as x is equal to 5. So I've basically written that in x variables we'll store the 5 value. Now after running the cell which is x is equal to 5, and when I just only say write x, so what it is showing output, it is showing 5. So basically a variable stores data, and you can give it any name following the rule. Okay, now suppose I declare a variable name, okay, and I say name is equal to in string, so I give a string value which is suppose Alice, suppose Bob, or Virat. So in that case we have assigned a value to the name variable. Now suppose I declare another variable, suppose I mention age, and I mention age equal to 25. So in age variable 25 value will be stored. So whenever I will print age, then I will get the value output as 25. So let's say you want to have a variable x that is equal to the value of 5, and then ask the computer to tell the value of that variable, type x equals 5, write x and then execute, and here's the result 5. So you can define the variable not only by x. Suppose I give a name of the variable as y. I suppose say y equal to 10. And when I just mention y and run this cell, what will happen? I will get value of y is equal to 10. That is the way of assigning values to a particular variable. Okay, so let's move on. Now next is reassigning value. So if you assign the value of 1 to a variable z, okay, so your output after executing z will be 1, right? I've assigned some value. I've assigned z equal to 1. And when I run that cell, and in another cell, when I say only Z and I execute the line or the cell, so what I will get? It will be one value because I have previously assigned the variable value as one. And after that, if you assign 3 to the same variable Z, so Z will be equal to 3 and not 1 anymore. So previously, what was the value of Z? It was 1, right? And after that, what I did, I assigned the same variable name Z and I give the value 3 to it. So after printing the Z value, what will I get? I will get 3, not 1. The previous value which was 1 was erased and new value was assigned to it. So it will be equal to 3. So Python reassigns value to its object. So you can change the value of a variable anytime. Now suppose I say x is equal to 10, okay, and then I print the value of x, I will get 10. I will again say assign the variable x and I say x is equal to now 20 instead of 10. So when I print value x, then what will I get? I will get 20. So reassigning can be done to change the value of a variable anytime. Next is indexing element. So individual characters within a Python string can be accessed using index. So whenever you want to assign any or access any values within a Python string, it can be used using indexing. And extraction is performed by specifying the character zero-based index within square bracket. Now suppose I say x is equal to Virat. Okay. Now I know Virat is a string value here because I have inserted what we can say the double inverted comma to the string value. So it will be naturally a string value. Now what if I want to access only the value of first character? So what will be the first character of Virat? It will be V. I want to access the V. So for accessing the value of V, I need to perform indexing. So that is the basic working of index. And extraction is performed by specifying the characters zero base index within the square bracket. Okay. So in square bracket, you need to mention the index number of which you want to access it. So it is crucial to use square brackets, and I need to mention the index value in the square bracket for indexing and differentiating them from the parenthesis or braces. So when I need to do indexing, I need to mention the index of the particular character in the square bracket. Now suppose I have a variable named text. Okay. Now in that text variable, I store value of a string called hello. Okay. So naturally, when I print text, what I will get? I will get hello value. Now I want to access the second element, that is the E. In hello, what characters do we have? We have H, E, L, L, O. Right. Now I want to access E. So what I will do? I will mention the name of the variable. Now what is the name of the variable in our case? Text. Okay. So I'll mention the name of the variable, that is text. And in square brackets, what I'll show? I'll say that I want to access the second element, that is the E. So what I'll give here as 1, because indexing starts from 0. Indexing basically starts from 0. If I give value as 0 in the square bracket, it will give me value H. Now I want to access E. So what I will do? I will give value as 1 in the square bracket, and then I will be able to access the value of E. So that is indexing element. So strings and lists are the two data types which are used for indexing to access specific characters or items. We will see that also in the implementation part. Now we have arithmetic operator. Python provides standard arithmetic operators. For example, plus, minus, multiplication, division, divisible, for querying, for performing mathematical calculations on numerical type. So these are the different arithmetic operators. When I want to do addition, so what symbol I will use? I will use this symbol. Suppose I have a variable named x and I mention value as it as 2 plus 2. So what will be the answer of x? I will get 4. The division operator executes float division by default, resulting in a floating point number even if both operands are integer. So suppose I want to divide a 6 by 2. Okay, what should I expect the answer to be? 3, but it will show 3 points. Whether it will be what we can say a whole number without a decimal point, the answer, but still it will give the float answer, that is in decimal number. So it naturally assumes that the answer can be the float to avoid the conflict. Now suppose I say 5 divided by 2. So at that point, our answer should be in point, right? So that would be the standard procedure. Giving answer while doing division, we'll get the floating point number, that is in point. And for precise division results, ensure at least one operand is a float. So example, we have given 16.0 divided by 3, or we can use the type conversions like float 16 divided by. So one more example we can see of arithmetic operators. Now suppose I have given a variable as value 5, and for b variable I have given variable as value as 2. So a is 5 and b is 2. So just I will say print a plus b. So what symbol should I use? I will use this symbol. So when I say print a plus b, so what will happen? I will get answer 7. So that is the different arithmetic operators. We will see them in the implementation part. Now here we have plus for addition, minus symbol for subtraction, for division, and we have a note that if you want to divide 16 by 3, when you use Python 2, we should look for the quotient of the float 16 divided by 3 and not for the integer 16 divided by 3. So you should either transform the number into float or type it as a float directly. Now as you can see here, this is used for divisible, so it will just give us the remainder here. Now when I say 6, when I use 6 this symbol and by 2. So what it should give? It will give answer as 0, because when we divide 3 are 6. So what will be the remainder here? It will be 0. So this symbol is used for returning remainder. We have this for multiplication and this for performing power calculus. Now next is the double equality sign. So in this, the single equal sign is equal to serves as assignment operator, binding value to the variable name. So when I say x equal to 10, so what will happen? Naturally, x variable will have the value 10. And when I print x, what will happen? I will get value as output as 10. So that is the single equal sign when we need to serve the, and it basically equal sign serves the as the assignment operator. Now what does the double equal sign mean? It functions as a comparison operator, testing whether two operands possesses equivalent values. So when I mention, suppose I give variable a as value 10. So what I will use? I will use single equal sign, a equal to 10. So now a variable has 10 value. Now when I print a equal to 10, so I have used the double equal sign. So what it will do? It will compare. What was the previous value of a? It was 10. So 10 equal to 10 means it will show output as true. That is the double equality sign, which is used as the comparison operator, and it tests whether two operands possesses equivalent values. Like another example, suppose I have value as a equal to 5. Okay, I have value of a variable as 5. So I will mention a equal to 5. When I print a, I will get 5 value. And suppose I introduce another variable b, which is, suppose I give single equal sign, b equal to 6. So what will be your sign show? When we print b, what will show? It will give 6. And when I print a equal to b, so what is the value of a? 5. 5 equal to 6. Are they both equal? No. 5 is not equal to 6. So it will give answer false. So it is used as a comparison operator. Now evaluating an expression with the double equal sign operator results in a boolean outcome, either true or false. So when we use the double equal sign, the result will be always in boolean values. Now what are boolean values? True or false. So when I previously mentioned a equal to b, a equal to 5, sorry, a equal to 5 and b is equal to 6. So when I print a equal to b, so what will it do? It will what was the value of a? 5. What was the value of b? 6. So 5 equal to 6, which is not the true case, because 5 and 6 are not equal. So it will show false value, that they are not equal value. That is the use of double equality. So as you can see, a double equality sign verifies the left and the right side of an equality are equal. So here suppose I give 5, here I give 6. So it will show, if I print the output, then what will happen? It will show false. Now here, not equal to, it verifies the left and the right side of an equality are not equal. So if I mention 5 here and not equal to 6, so what it will show? It will show true, because 5 is not equal to, so it will show true. This symbol is used for greater than, we have this for less than, we have greater than equal to, and we have less than or equal to. These are the multiple signs we use to compare two values or multiple values. Here we have seen the comparison operator starting from double equal sign, not equal to, greater than, less than, greater than or equal to, or less than or equal to. Now for example, now if I assign x variable as 5 value, okay, I have x variable as 5 value. So in x variable I have stored 5 value, and I want to check if 5 is greater than 3 or not. So what I will do? I will just say print x greater than 3. So it will check, is 5 greater than 3? Yes. And so in output we will get true as answer. That is the comparison operator we can use for comparing two values. Like if I want to compare is 5 greater than 3, yeah, we can check using this symbol. If I want to check if any number is lower or less than, so if I say if 5 is less than 3, what it should show? it should show false. That is the comparison operator. Then we have the logical operator. Now Python employs not, and or as logical operator to evaluate the truth value of expression. These operators return Boolean results true or false based on the logical relationship between operands, and a defined order of precedence governs their evaluation. Not has the highest property followed by the and then or. So these are the logical operators. Now in case of, and you guys may have heard this in previously in electronics like AND gate, OR gate, NOT gate. So in this case, the AND basically stands that all the conditions are true. Okay, AND is used when we have to see all the if all the conditions are true, and OR is used to check if any of the condition is true or not. Now, for example, suppose I want to check. Suppose I have a variable name x and I have value of 4. So what I'll do? I will say print x is greater than 2. Now, what was the value of x? 4. Is 4 greater than 2? Yes, it is greater than 2. And I will mention and here. Print x greater than 2 and x is less than 6. Is 4 value less than 6? Yes, 4 is less than 6. So our both conditions are satisfied here. X is greater than 2. Yes, 4 is greater than 2. And x is less than 6. Yes, 4 is less than 6. So we will get the answer as true. That is the logical operator. So in not gate, or sorry, the not operator, what is the description here? So it leads to the opposite of the given statement. So example, if we say not true, then what will be the answer? It will be false. If I say not false, so it should naturally give the answer true. And in this case, and it will check whether the two segments around it are true. For example, true and false leads to false. If I mention true and true, it will lead to true. If I say false and false, both are same, so it will lead to true. That is the and operator. And this is the or, where we check whether at least one of the two statements is true. For example, false or true will lead to true. I will say true or false will also lead to true. That is the logical operator. Now next is the identity operator. So Python utilizes identity operator is and is not to determine if two variables refer to the exact same object instance in memory. And these operators compare object identity with differ from equality operators that compare object values. You will understand better with example here. So when I say 5 is 6, so it will show false because 5 is not equal. 5 is not 5 has some specific value, 6 has some specific value, and say when I say 5 is 6, so it will show false. When I mention 5 equal to 6, which is also not true because 5 is different and 6 is different, so it will show false. When I say 5 is not 6, right? 5 is not 6, so it will show true. If I mention 5 is not equal to 6, that is also true. So these are the identity operators. Now we have the line continuation. Python permits the division of a single logical line of code into multiple physical lines using the line continuation character, and placing a backslash at the end of the line signals to the interpreter that the command continues on the subsequent line, improving code readability. So if you don't have space or to avoid the confusion, what we'll do, we'll continue the first line of code to the second line by using this symbol. So as you can see in example here, there is one line of code, and then we use the backslash symbol, and we use the another line of code where you mention 5 here. So these are same line of code. Okay, but I just need to avoid the confusion. So what I did, I used the backslash symbol and I continued that line of code in the second line. So you can split a long line of code using backslash or by wrapping in parentheses. So parentheses can be also used if you want to split a long line of code. Now summary for this part is that Python has a simple and strict syntax, right? That it is very simple, but we should follow the rules or else we will get the syntax error. Then we have the indentation matters, and variables are very easy to use, and operators also help us to compare, calculate, and also make decisions. And clear syntax helps you write clean and readable code. So now let's move towards the implementation part.